Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over section 9.1 of our series on introductory statistics. We're going to be taking a look at how to read line or dot plots in this presentation. So a sample problem of what we're going to be looking at is given here. You have this line plot, and you have to find how many books have 4 words in them. Don't forget there are practice problems at the end of this tutorial for you to try out to demonstrate mastery of the contents of this tutorial. Alright, so let's take a look at question number 1. We have a statement, some questions, and a line or dot plot here. So question 1 reads, some runners ran a 5-kilometer race and their times were recorded in the line plot below. Okay, so before we start on this problem, let's talk about the different components of a line or dot plot, okay? So whenever you see a line or dot plot, first thing you notice is that it has a title, all right? It basically tells you what the whole graph represents, what the plot represents. So we have the title, all right? And then you will have a horizontal line above it. It will be populated with dots, or sometimes X's are used in place of the dots. Okay, so they mean exactly the same thing. All right, so these dots, the number of dots or crosses that are present, represent the frequency. Okay, so what does frequency mean? How many times does that data point occur? Number of occurrences. Okay, number of occurrences, very important. So for example, if you look at 26, how many dots are above it? Just one. So that means this data point 26 occurred just once. All right, so the data points represent the frequency or number of occurrences of the data point beneath it. Okay, all right, so you have the title, you have the frequency, and then you have the numbers that are attached to the axis, and you also have the units at the bottom. Okay, so these units are attached to the number. So for example, this number right here is 25. What does it mean? What's the unit for 25? It's 25 minutes. Okay, and the number of dots above it tells you how many times this statistical point of 25 minutes occurs in the entire data set. Okay, so don't forget you have title, frequencies were captured by the number of dots, you have the numbers, and then the units. So that's basically the key components of a line or dot plot. All right, so let's go ahead and attack the questions. The first part, it says how many runners ran 5 kilometers in 25 minutes. Okay, so all of these data points represents the 5-kilometer race because that's what the title tells you, right? So we're looking for how many ran 25 minutes. So what we just have to do is take a look at, identify where 25 is. So between 24 and 26 right here is 25. And then we count how many dots or crosses are vertically above 25. Okay, they all stacked up on top of each other. So 1, 2, 3, 4. This vertical orientation of data plots or points represents the number or frequency of 25 in the data set. So there are 4 of them. So what does that tell you? It tells you that 4 runners completed a 5K in 25 minutes. Okay, so the answer to number 1 is 4. Let's put this in red. Is 4 runners. Bam. All right, let's move on to the next question. Question number 1B. Let me just box my answer real quick. 1B, what time did most runners take to complete the 5K? Okay. All right, so in this particular case, we're basically looking for which data point occurs more frequently or the most number of times. The beauty of line and dot plots is that it represents data in a very visual way, which makes it very easy and quick to work with. It's a very efficient way to organize data. So just by simply looking at it, you ask yourself, for most, we're looking for, kind of sort of think about it as the tallest organization of points. Which one goes up the most? Which one has the most number of points? Which data point? So 20 has just one dot on it. 20 is just one. Okay, let's stack them all. So you see 20 is just one. 25 is 4. 26 is 1. 31 is 1. 32 is 1, 2, 3, 4, 5. 33 is 1. 34, 1. 35, 1. 41, 42, 1. Okay, we didn't have to do this. Just by looking at the point, graphically, you can easily see that the data point 32 spans the highest, is the tallest stack of points. All right, so just by observation alone, you can easily tell that this is the time that most people spent, because it's the one that has the most frequent occurrence. All right, so what time did most runners take to complete the 5K? It's the time. So what's the unit of time? Minutes. So it's going to be 32 minutes. Always append the units with your answer so you can understand what your answer signifies. All right, so 32 minutes is the time that most runners took to complete the race. So let's box our answer there. Okay, question number 1C. What is the difference between the number of runners that ran at 26 minutes and 32 minutes? So we're going to do some arithmetic here. We have to determine the number of runners that run 26 and the number of runners that run 32. So what operation does difference suggest? Difference is just a fancy way of saying subtract. Okay? So we're looking at the subtraction operation. So what we're going to be doing is number of runners that it's 26 minutes minus number of runners, or let's switch it around. Let's do number of runners that did 32. It doesn't really matter. Number of runners that did 32 minutes minus number of runners that did 26 minutes. Okay? Since we're looking for difference in the two, it's basically like an absolute value type situation. All right, so how many runners did 32 minutes? 5 runners did 32 minutes. How do we know? You count the number of points above 32. 1, 2, 3, 4, 5. So 5 runners did 32 minus how many did 26? Just 1 runner. So what's the difference between 5 and 1? The difference is 4. Okay, so the difference between the number of runners that did 26 versus 32 is 4 runners. That's the difference. All right, we're going to take a look at another example and then give you some to try out. All right, so let's box our answer for question number 1C. All right, number 2. It says the heights of some adult males were measured and recorded in the line plot below. Okay, so we have the line plot. You see the title, you see the frequency points, the numbers, and the units. All right, so it says, what is the difference between the number of adult males that are 66 inches and 74 inches? All right, so we are doing something similar to what we did in 1C. We're looking for the difference between two data points. So 66 and 74. So number of males that did 74 minus number of that measure 74, sorry, minus number of males that measure 66. That will be our answer. All right. So if you look at 74, how many points, how many times does 74 occur? How many males had that measurement? You count the number of points and it's 2, right? How about 66 inches? Just 1, because it's only 1 point, 1. So the difference is simply 2 for 74 minus 1 for 66. So it's just, the difference is 1 adult male. there you have it. Okay, let's take a look at number 2b. How many adult males are 74 inches or taller? Oh, so here we are looking at a range. Okay, so 74 inches or taller basically means that we're going to focus our attention on just a part of the entire data set. What is it? We're going to look at 74 and everything to the right of 74. Okay, so let me just show you something real quick. So it's as though we're just looking at this portion of the entire graph. Why is it just this portion? Because those are the only data points that are 74 or taller. Taller means greater, right? So just count the number of points that are above 74 or greater, basically from 74 to 80, because that's the range that fits this particular interval. All right, so how many dots above the horizontal line? How many dots are there from 74 all the way to 80? If you count them, you have 1, 2, 3, 4, 5. Are there a total of 5 points? Okay, so how many adult males are 74 inches or taller is basically 2 for 74 plus 1 for 76 plus 1 for 77 plus 1 for 80. All right, and then when you add them all up, you can just count them or do the math. Your answer is 5, and the unit is males. 5 adult males are 74 inches or taller. Okay, all right, let's take this out of there. Okay, the C part. How many adult males measure 70 inches? Okay, so this one is pretty straightforward. We identify 70 inches on the axis, so that's 70 right there. And then look at the frequency. How many dots are there above it? There are 2 data points, 2 points above it. So that represents 2 adult males. Okay? So the answer to 2C is there are 2 adult males that measure 70 inches. All right, the last question is how many adult males were measured in total? So what do we do here? We'll look at the entire range from 64 to 80 and we count the total number of points. Okay, let's do it. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are a total of 15 males that were measured in total. So 15 adult males were measured. All right, so that's basically how to read line plots. In the next lesson, 9.2, we're going to be going over how to actually graph it. All right, so now is your time to do some practice problems. All right, so here are 2 practice problems we would like you to try out. So go ahead and pause the video presentation at this time and try these 2 questions. When you're done, click on the playback button and we are going to reveal what the correct answers are. Oh, just a minute, a quick correction on D, 1D. How many presidents were older than 64 years at inauguration? Alrighty, welcome back. Here are the answers to question number 1 and 2. Go ahead and check it out. Let us know how well you did in the comment section. If you did well on these problems, go ahead and destroy that like button for us. If you have any questions, specify it in the comment section below, and we'll be more than glad to support you. Thanks so much for taking the time to support this channel with your view. Don't forget to visit our website at Mathgotserved.com for tons of support resources to help you master your learning and do well in your current math class. Until the next time, have a wonderful